So today we're going to use the skills that we have learned so far to solve real-world problems. For solving optimization problems, there are actually certain steps to follow. The first step, of course, is to read the problem and understand it fully. Understand it. And then the second step is to translate it into mathematical terms and sometimes geometric terms. The third step is to build a function that about the quantity that you need to optimize, for example, x squared plus 2x or something like that. And then use the method that we learned before, the closed interval method, to find the maximum and minimum value of the function. All right, so now we're going to follow these steps to solve this problem. Farmer has 1,200 meters of fencing and wants to fence off a rectangular field that borders a straight river. He needs to know fence along the river. What are the dimensions of the field that has the largest area? So now we're going to use the second step to translate the problem to understand it better. Basically, we can draw a river, and then the farmer has a 1,200-meter fence, right? So we're going to use green. We're going to use actually, you know what? We're going to use red color to stand for the fence, and the fence is going to be rectangular along the river, and there's no fence at the water side. So the whole length of this side, and this side is going to be 1,200 meters. We need to help the farmer to find a certain way to set up the fence so that he can have the largest area over here in this rectangle. All right, so how about we let the length of this side be x and the length of this side be y? Basically, we can express 1,200 meters as x plus 2y. So y, it is literally equal to 1,200 minus x divided by 2. And then we can express the area, whatever you want to use, like ax, function of x, the area of the rectangle can be expressed as x times y, which is x times 1,200 minus x divided by 2. And that can be simplified as 600x minus 1 over 2 x squared. All right, so that's the function of the area. Now, the problem actually asks us to find the maximum value of this function. We're going to use the closed interval method. First step, we have to find the derivative of ax, right? So the derivative of ax actually is equal to 600 minus x. When the function of ax has the maximum or minimum value, then the derivative of ax should be 0, and this one should be 0 when it has a maximum. Then x has to be 600, and then y should be 300. If you put x into this function over here, then it's easy for you to find the value of y. The maximum value of a actually is 600 times 300, which is 180,000. And if you check it for each endpoint of the function, the area would turn out to be 0. So it wouldn't be the greatest number that we're looking for. And then this answer is verified. All right, guys, have a nice one. I'll see you guys next time.